I'd like to introduce our next speaker, who is Arnold Offner from Phoenix Contact. Arnold has more than 30 years of experience in the field of industrial automation, and he's been involved in the APL project since 2018 and collaborated on numerous technical articles on the subject. Arnold, I'm now going to turn this over to you.
Thank you, Liz, and hi to everybody attending this webinar. So part of my conversation today is the conversation, firstly, of how did we get to where we are with regard to Ethernet-APL? What are the lessons we could learn? And as part of my abstract, I just wanted to make something perfectly clear. It could not have been done without teamwork, and it could certainly not have been done with an individual or an ivory tower outlook into how we did this. So my presentation today is to briefly take you through the conversation of the history of how we got to APL in just 5 short years from idea to prototype stage. And the first thing I'll begin by stating is that SPE and Ethernet-APL are simply physical layers. This is not another bus. This is not another field bus. This is actually the result of a very collaborative process in defining what an industry needed and then figuring out who those stakeholders needed to be, and then making sure that the relevant end users also fully understood and got their wish as to what they needed. So I'll start by saying that the most important parts of the Ethernet-APL project was in fact the 4 standards development organizations. We refer to them as STOs. And if I was to mention Profinet, it's because of TIA International. If I mention Part IP, it was because of the Steelcom Group, the OPC UA technology from the OPC Foundation, and of course, Ethernet IP from the ODBA. As I said previously, Ethernet-APL is just that, a physical layer, which means that this design was done as a protocol-independent technology. It had to be easy and robust to connect and to install and commission. And what we really did was we took a single pair wire, added 10 megabits together with power, and made it essentially exciting enough for the hazardous environment. The one thing I'll also say that's very important is that Ethernet has certainly proved to all of us how this state-of-the-art technology can be used and deployed, and so it had to be both easy to install and easy to use. One of the most important things, however, that started the Ethernet-APL project is, in fact, the Namur NE 168. This document essentially describes an Ethernet-based communication system. And when it was updated in May of 2024 last year, it still recommends Ethernet IP from the ODBA organization and Profinet from Profinet International as the 2 preferred Ethernet protocols. On to the project itself. Together with the 4 STOs, we had 12 companies that originally set out then to develop the technology. And before I go into more information regarding those companies, I do want to be more specific about what these 4 STOs have accomplished and what they're responsible for. So the Steelcom Group's responsibility in the project was tied to conformance testing and compliance. You could also say interoperability. In other words, making sure that the APL physical layer works well on a device, a field device, whether it's a sensor or an actuator, or making sure that the port on a switch is capable of delivering the APL signal. The ODBA was responsible for marketing and promotion. The OPC Foundation's task is related to device data, and you're probably going to hear a lot more of this in the future. The 2 technologies being SDI, better known as Field Device Integration, and PADIM, Process Automation Device Information Model. And this is the information modeling that's required with this kind of digital data. And then, of course, PI International was involved in what I would call the definition of the technology and the incorporation of intrinsic safety into APL. And so Ethernet-APL essentially becomes a modification for the industry, the process industry, that then incorporates all of these technologies together. It's, of course, a very extensive list, and I'll let you read this in your own time, but these are the various standards and also technical specifications that were created during that time period of the APL project. And of course, the laundry list of items for the Ethernet-APL project from 2018 to August of 22, when it was successfully announced and completed, involved firstly the deployment of T1L as we know it, the creation of the 2-wire standard, and the technical standard we know as 2-wire intrinsic two-stage Ethernet, the definition of the APL port profiles, the creation of an APL engineering guideline, in other words, a 120-page plus document that defines everything one would need to know in written form about APL, and the test that continues today, which revolve around the APL conformance test. I did want to just briefly touch on how we do things in Ethernet-APL, only for the sake of clarity, in letting you know that nowadays intrinsic safety has become far simpler with Ethernet-APL. And so we have a 4-letter code which basically breaks down how these devices are to be connected or interconnected with each other. We talk about a segment class. In other words, in this case, a SPE. Every field device is connected to the SPE of a switch. And so that would be the device both on the switch and on the field instrument. More importantly, the port class, the very next one, tells us whether it's a power source. This would be the connection on an Ethernet switch, or it's a power load. In other words, it's the load consumed by the field instrument connected to that particular port. Power classes are very important, and what I've done here is basically list in black the letters that currently are available, with in red the options that are still on the table once 2 members of the APL project or the APL community are able to both deliver a switch and a field instrument. And so in power class A, we're looking at half a watt. The 0.04 milliwatts is actually used to transmit that 200-meter distance we speak of. And then the final A, as we break down what SPEA means, refers to an XIA type device, and that is where we use blue connectors per the intrinsically safe recommendations of the industry. So breaking it down very simply, as my slide points out, SPEA connects to your SLAA. And what's very interesting is that a power class B could power both an SLAA or an SLBA. And if you have any questions, feel free to contact me when you get a chance. My very next slide is just to give you a breakdown of what the engineering guide consists of. And I'll highlight 2 specific areas that I think are very pertinent to the industry. Chapter 4 discusses the planning process of APL networks. In other words, how to do that effectively. And chapter 10.4 has a very interesting document, which one could consider the specification text for design and consulting engineers who are now going to be recommending the use of APL in future projects. In closing, what I do want to just cover is to let you know as to where the APL ecosystem is as of last month, August 2025, and let you know that the group of 12 companies has now grown to a total of 15. And you will notice here too that we have started discussing the topic of safety. We have also started discussing the topic of bringing other key players into our ecosystem so that the APL product portfolio can be grown and that it can also be more, shall we say, widespread and be more accepted globally. As I started my presentation, I did say that collaboration is key. And so my call to action to all of you, as we consider all the other ways in which SPE could be used, would firstly need to consider, as I say, get all the stakeholders together. It's important that you get all the key standards development organizations, your end user groups, your user communities, and your OEMs, and you set yourself a fixed time of collaboration. Like I said, we did it in 5. That's also because of the lengthy EX certification requirement. But I think a technology like this in factory automation or building automation or transportation of energy could easily be done in 3 to 4 years if structured correctly. As I said, APL is just a physical layer, and so too is SPE. And so it's very important to consider that in order to make this work for all these parties, because no one single company can provide the technology, conformance, compliance, and interoperability test standards are going to be key. And so developing the engineering details need to be shared with all the interested parties to make this happen. And in this way, I believe we could create a global ecosystem to allow all designers to develop solutions using the SPE technology. And one could also think about developing incubators or test cases to better define the use of SPE. Phoenix Contact has already deployed the use of SPE in our new Catan building automation controller. We use SPE as a communication media of up to 1,000 feet between units. Our first managed SPE switch has been around now for 2 years. And what we're doing is we're launching our brand new 12-port APL switch, which is half the size of our 24-port switch. And with that, I wanted to thank you very much for attending the presentation. And if you have any questions, please feel free to ask them now or to reach out whenever you get a chance. I'm signing off now. I'm Arnold Offner, the self-appointed SPE and APL ambassador at Phoenix Conference. Bye.